Welcome. Good morning, afternoon. We just ate, so maybe morning again. All right, so like you said, my name is Shannon. I actually just help people find the right monitoring tools in order to grow sustainably and be able to take advantage of that velocity that you get from modern applications. And I came to this honestly. So like he was saying earlier, I'm actually a software developer by trade, and I started right out of high school. And I thought, and excuse my voice, but I'll do my best, but I thought that I was Superwoman. Anyone else here feel that way when you first got started? Yeah? No. A couple of you. I did. And I started writing software, and I did pretty well for a while. And I actually climbed the ranks, built software for companies like Logitech, Excite at Home, and the like. Excuse me. Eventually, I ended up being hired to do management consulting. And so I go in and take a look at architectures of companies that had trouble deploying their technology, right? The product wasn't moving forward. Potentially they had architects that left, or they had architects that hired people that weren't smarter than them. You know, whatever the issue was, they couldn't move their business forward. So my first implementation of this did pretty well. Again, I went in with my mentor, we did an assessment, made some changes, hired new developers. I'm not exactly the most popular person in the room right now for this, but we did, and we did it successfully. So we were finally hired to a company, and it was my dream job, okay? The CTO was Al Alcorn. Anyone know who that is? Pong. He invented Pong. One of the first the guys from Atari. He was my hero at the time, right? I took my Atari part a few times as a kid. Probably a few of you did too. Amazingly, the same thing, the chief scientist was Avery Wing. Anyone know who he is? Like, I'm name dropping, but it was really exciting for me because I came right out of high school, ended up working for these guys, and he's the guy who wrote the algorithm for Shazam that you use today. So I should have been intimidated, but I wasn't because, of course, I was Superwoman, okay? So I went in, got a new architect, we made a bunch of changes, everything was written in Perl and using the free version of MySQL, and we were dumping gigabytes into that database, and it was crashing for what? 8, 10 hours a day. Easy win. I knew what to do, right? All of you in this room know what to do. You fix it. Pull the bits out of the database, get better infrastructure, move to modern languages. Probably don't write everything in Perl because you can't hire developers to help you out, right? And it was like a golden opportunity for me. So I went in head first. Okay, so fast forward a few months, everything's working better. We don't have 8-hour outages, our customers are happy. Amazing, right? Well, the old architect didn't think so. He was pretty mad, and he was also really good friends with the CEO and with Al, who I was trying to impress. And at this point, I don't know if I did a very good job. So he goes to Al and he says, hey, she's doing it wrong. There's something wrong. I'm right, she's wrong, she's bad, I'm good. All these things happen. That's okay. That's okay. And I thought, no problem. So they put us all in a room, and I thought, yeah, we got this in the bag. We're going to show them the product. Everything's working great. And Al goes, okay. So you're saying it's faster. Show me. Show me the measurements. And my heart sank. I had nothing. I really didn't. I had no monitoring in place. I had no measurement in place. We were just going, trying to fix the problem because we knew what to do. But we failed. We did. I came to this honestly. I failed. I failed my team. And I failed myself, and probably failed that relationship with Al. So I came to this thinking, okay, I need to do something different. So I started working at companies like New Relic. And that's what I'm going to talk about today, is kind of the evolution of monitoring. And hopefully, by the end of this, you'll take some stuff away. So first, what does Epsagon do? Full disclosure, this is not an infomercial, but there are belief systems inside of my company that I believe in. I truly believe it's the way to go when it comes to monitoring. So that you know what Epsagon does, we are a monitoring tool, a lot like New Relic, but we're focused on highly distributed architectures, serverless, and some containers, so microservices. And we do that with our own bespoke technology, and we focus on distributed tracing, which is why they have me here today talking about it. Okay. So outside of that story, embarrassing story, what we're going to talk about is how is serverless different than other applications. We'll give a high level of what serverless is. I know a few of you had those questions. What's stateless and why is it relevant? I'm not going to teach you about stateless. You know what that is, but I can tell you kind of the gotchas with a stateless environment. I'll talk to you about how to handle errors in this environment and talk about, of course, distributed tracing all throughout. And then at the end, I really want to talk about how I can help you, okay? Not through my product, just how can I help through the experience of myself and the customers that we bring. Okay? Serverless. How many people use serverless today at work? Okay, a handful. How many of you kind of know what it is? Okay, cool. So serverless it's pretty easy. You're not managing your servers. There are servers. It's a misnomer in some ways. It's a big debate, right? John is laughing because there are actually servers, but you're not managing them, right? So there's a managed service, or maybe you have something on your private, but I'll talk about managed services today in context, and afterwards we can talk about private cloud. But you have a managed service that you're basically saying, okay, allocate me this amount of memory, event-driven, and I'm going to pay for time. So 100 milliseconds at a time of compute, and that's it. Okay? Everything else is managed. I'll set the max memory limit, the timeout limit, and they're going to allocate and manage everything else. Okay? So that's what serverless is per Wikipedia. But anyone who works in serverless also knows that serverless is not just functions. It's not. It's an entire ecosystem. In fact, our chief architect would tell you that it's a community, because serverless is an entire system. You cannot do everything on a tiny little function. You have to use services. You have to. And the tinier the function and the more distributed we get, the more services they are. And that's the community, right? Every day we're seeing more and more technologies come up that people are using. Even out there, third party, seen it, geolocation, right? That is a part of your serverless system, because remember, you're paying every 100 milliseconds. So that connection out through a third-party API, that's part of your cost. Okay? All right. Why do people go to serverless? We heard in the DDD discussion, if anyone was there, it was amazing. You can break things into tiny pieces, okay? The cost when people are using serverless, it goes down probably by 90%, your compute costs. There's also below the waterline benefits, like out-of-the-box auto-scaling, DevOps, like low operational overhead. That's why a lot of data scientists love serverless. And then there's the increase in developer velocity. It's not unlike the microservices discussion. As you're breaking things into smaller pieces, right? It's easier to build faster and faster, easier to maintain, easier to understand where in your architecture is most important, where you should focus your time in refactoring and move on. Also, easier to onboard new engineers. That's also true. We've seen that every day. And the most important thing, and I talked to someone about this just before the talk, is you get to focus on that business logic. Think about it for a minute. If your compute, let's say it's event-driven, and you have a function, and you have to say, hey, function, go do something. Imagine that that's your architecture. Now think about the fact that you can probably track, you can track exactly the flow and the compute for a single person. You no longer have a server with a bunch of services running. You're actually in an event-driven application. So one user, an event throughout your system, you can actually track and understand the cost metrics per customer. So you can focus on that business logic and iterate faster. Okay. All right, properties of serverless applications. Serverless is microservices. They're highly distributed. I'm going to show you a couple of real-world examples. Event-driven, right? And you have to use managed services. Okay? You're not going to have a function that has a 15-minute limit that goes out and does authentication, and then it creates an entry in the database, and so on and so forth. You're not going to do that anymore. You're actually very event-driven, and you're utilizing managed services. And what we've seen, actually, and what I've seen over time is as people are growing into their serverless footprint, they're increasing the number of services exponentially. So you'll see things like Stripe and Auth0 and Redis and so on. Make sense so far? Are we awake? Good. All right. It's not the promised land. It's not without concerns, okay? Limited memory. It probably makes some people nervous, right? Because I don't know about you, but I've never written code where I could tell you how much memory I was going to use beforehand. A little nerve-wracking, okay? Limited running time. It's true. You set a timeout. 15 seconds, or 15 minutes, that's what you get. Cold starts. Anyone know what cold starts are? The dreaded cold start. Right, so if you have a function, like you have some code and it's been running, that's fine, because it's been running, it's up and running, so on. Maybe it's on a server, however they do their magic behind the scenes. The fact is, once you haven't run the function for a while, and then you set an event that wakes that function up, sometimes you have a server that starts up. It's not as bad as your face says, though. Actually, the overhead's maybe about 10%, and when your infrastructure costs $6, it's not as much as you think. But it is something that people are concerned with, and Amazon's working on it. And last, I don't think it's a limitation, but people think this statelessness is a limitation. This is actually the intended result of functions as a service. It's supposed to be stateless, and there are all sorts of design patterns around that people are using today in order to build serverless applications. There's some other things that we can talk about. You'll hear about costs of concurrency limits and so on, and we'll talk through it. All right, this is a real example. This is HSBC. This was shown at this year's reInvent. Excuse me. And this is their solution overview using a serverless application. What I mean to show you in this slide is not whether or not this is best practices when you build an application. It's just to tell you that people are. Serverless is coming, whether you've let it happen or not, and there's insurrections happening all over enterprises. I can tell you because they come to me and tell me, okay, I've kind of broken the rules, how can you help me? Okay, so serverless is coming, and even banks like HSBC are doing it. Now we get to the challenge, and again, I keep pointing back to the DDD discussion. I'm sorry for people who haven't been there. I suggest you watch the talk. It was brilliant. But essentially, it's the same challenge as the complexity challenge, okay? You're taking a simple application, breaking it into itty-bitty tiny pieces. You're using third-party services for things that aren't your core competency or aren't core to your business. And this is an actual example done by one of the top experts in serverless, Jan Kui. If you want to know about serverless, his talks are amazing. But this is an actual example of how he re-architected something for a client using serverless. And that should scare you. Does it scare you? Because it scared me, right? It's okay. The benefits are there, just as I talked about before, and I'm here to help you make sure that that's just not as scary as it looks like. Okay? The community agrees that that's scary, right? They're saying that debugging, monitoring, testing, monitoring, debugging, over and over and over again, observability comes up a lot. These are the problems that they see when building serverless, but even with those problems and those shortcomings, they're still going serverless because the benefits vastly outweighed the issues. So let's talk about troubleshooting. How do you troubleshoot that, right? Most people are used to focusing on a server. I am. Okay? I was at New Relic. We had APM. We had agents that we would automatically deploy to make sure that we had visibility into architectures. It doesn't exist there. You can't put an agent on a 40 millisecond Lambda. It doesn't make any sense, right? The overhead alone would cost more. You also can't add code, but we'll talk about that later. But how do you do it? So most people, like I said, are really uber focused on the Lambda itself or on the function. It's because that's what they know how to do. That's what they've done. And a lot of the tools that you're seeing coming out of these big guys and some of the new guys really focus on the function. But the problem is, inside of a function, you may only have 15, 20 lines of code. So that bytecode instrumentation, what does it mean? What does it mean? On top of that, yeah, it's important to understand how your function's running, and maybe you have a slowdown, or maybe you have an error that happened, and maybe that error was well, commented. But as a developer, and I can tell you that my comments weren't always relevant. And we see that every day with all of our customers, and we have hundreds and hundreds of customers on our platform today where they have like an exception and they have no idea what happened. They just know there was an exception. And then what they do, they start opening up logs. CloudWatch log, after CloudWatch log, after CloudWatch log, and they got the common story to me is they got 6 to 10 tabs open with logs where they're trying to do a correlation. And some of them have Splunk. Maybe a lot of people in here do, right? Or some sort of log aggregation tool or Sumo Logic. And they've dumped a bunch of information, created custom identifiers, and hopefully have some sort of correlation, but it doesn't help them. You think you can take a look at the log and it tells a story. Maybe you can connect to the host, you can run a debugger, but that doesn't apply in a fast environment. So we had agent-based monitoring. I want to give some props there. It is persistent. You can instrument your application code. It gets infrastructure metrics, application metrics, does the correlation. It stores, compresses, sends data, but it relies on a state. Okay, these guys, they do sampling, they send you information back every 5 minutes, and for traditional applications, it works. I believe in it because I worked there. I know that it works. The problem is it doesn't work for fast. Why? It's event-driven. It's stateless. Right? There's no server for you to connect to. There's no current state. You can't really determine your system health. And a lot of times it's ephemeral, right? Things come and they go, and it's asynchronous. Maybe you have multiple lambdas that are dumping stuff in Kinesis that's hitting a lambda that's going through the same processing, and at the same time you have another lambda coming in, right? Or, these, as services grow, and as AWS and all the other managed service providers evolve their tooling, we're more and more dependent on them, but they add more and more complexity, and being able to handle and understand your asynchronous and distributed environments become more and more important. And I'm saying it over and over again because you have to really think about this as you code, as you build serverless applications. Okay? You can't store the log, can't install an agent, information needs to be sent right away. So how do you handle errors? There's lots of types of failures. We have the basics. Unhandled exceptions, timeouts, out of memory. These are unique to serverless because you set a memory amount and you set a timeout for your function. And the functions are important, so you certainly need monitoring on the function. You need to understand if you've allocated enough memory, for example. That's something you really need to know. And make sure to look at the percentiles, because the fact is, if you're not looking and you're just looking at average and you have a 40 millisecond function, and all of a sudden it's hitting 5, 6, 7 seconds, what do you think your bill's gonna do? Multiply it by the billions. We've had people come to us with $50,000 bugs because of things like this. Error conditions that result in retries, okay? Who knows what a retry is? Yeah? Okay. Retry behavior. AWS services, a lot of services, when there's an error condition, you can code in retries. Something happened that was wrong in the chain. You can code it in. There's also asynchronous events and stream-based events inside of AWS, like SNS and Kinesis, that have their own retry rules around a failure. So for example, if they are trying to send data to a Lambda and it times out, they're going to try again and again. There's throttling mechanisms inside of AWS. If you try and send data, from the same Lambda 5, 6, 7, 8 at the same time, you can't. So it throttles it and then tries again and again and again and again and again. And your AWS bill goes from a couple $100 to 10, 12,000 like ours did one month. So you need, yeah.
Can I ask questions now?
Please, yeah, we got 45 minutes and I think I'm boring people.
So this is happening because, let's say I send and it fails, I retry and send it again, and now it spins up another instance of the function.
Yeah.
And that's
It's going to keep trying and trying and trying. That's right.
And
That's right. So all of a sudden your cost triples or 5 times, right?
Eventually they'll stop running the time.
Yeah. It depends on a certain amount of times for these retry mechanisms and asynchronous events, but stream-based are even better. It's your data timeout. So if your data doesn't expire for 7 days, it is going to try and hit your function for 7 days straight. Okay, imagine what that does to your health. But, the consequences. We know what the consequences is. Retries may happen. For them to succeed, the code idempotent, obviously. Again, this is in the other tool. In this kind of environment, you can try from a coding perspective to deal with this. Just make sure your code is idempotent. Like, make sure that if it happens over and over again, it's okay. Like, maybe you update the same database entry. That's okay. Maybe you authenticate a user again. Meh, it's fine. Whatever. You check if a file exists. These are the types of things that you can build idempotent. But the fact is, having your developers be more like highly velocitous environment, going really fast, and then also having to make sure that everything that they build is idempotent, it's a lot of work. It's a lot of work, and you can't track it and you can't manage it. So now that I've scared you, there are certain ways that you can handle this. I know we haven't talked tracing yet, but I want to make sure you understand that there are things that you can do. There are serverless orchestration tools inside of place like AWS, things like step functions, where if you have a series that needs to happen and it's dependent on each other, you can use something like a step function to orchestrate this functionality, and then you have to do a little bit of work to backtrack and make sure if it's a full-on error, it's never going to work, everything's cleaned up. So that can happen. But when you deploy it, and this is serverless framework, the most popular serverless framework, it's going to look a little bit like that. It gets messy. It gets complicated. I'm not saying don't do it. I'm just saying it's not the solution. So what have we learned? That observability, it's a challenge, and it's still a challenge. And there are a lot of tools out there that are trying to help, including the step functions that we talked about. But that's still not going to let you know what happened from beginning to end. Okay? So remembering that systems are functions, that a function like serverless is not just a single function, it is an entire system. Okay? That tracking system health, you're looking at something like this. Okay? All right. So we need to be able to track an ever-changing ephemeral environment and asynchronous events. We need to take this same image and have it look more like this. Okay? How do we do that? So today, I believe the answer is tracing. How many people here are familiar with tracing in software? Okay. You know what it is conceptually, right? You're tracing something through a system, right? Okay. Now with serverless, you're not just tracing something through a system, you're also tracing asynchronous events. You're tracing your non-AWS resources. So how do I implement tracing? Well, distributed tracing is not new. We did not invent it. My company didn't invent it. My CTO didn't invent it. There's a ton of information about it, and it really does tell the story of a workflow. Bidirectional, asynchronous, ephemeral. A trace will tell you what happens when someone hits your API gateway, hits a Lambda, goes out and authenticates, comes back, maybe dumps some data in a data store. That maybe triggers another Lambda to trigger another change in your architecture. Maybe that triggers a purchase with Stripe, and so on. Distributed tracing is the answer to track all of that. Okay? And in fact, there are open source tools, and we were talking about that earlier. There are some standards out, open tracing, we'll talk about them in a minute, open census, and there are distributed tracing tools out there that are free. So I want you to know that these things exist and that they work. So Jaeger, for example, is one distributed tracing UI. You can see kind of the timeline, and it gives you a better understanding of that end-to-end transaction. Okay? So please, if you're thinking about open source and a free technology, Jaeger's a great technology. It's built on top of open tracing and so on. So if you want to implement distributed tracing without an agent or a library, okay, what you're going to do is you're going to add manual tracing and instrumentation. There's open tracing, open census, and you'll include the library, and then you'll add calls in your code before and after, and at the end of each microservice. Okay? This is going to track exactly what happened. But remember, you're adding code. Our argument as a company is that eventually, and all of us have been there, we're all programmers in the room, so you're in the middle of the night, you're trying to get something out the door, you're coding, you're barely getting logs out. How many are developers in that high-pressure situation, which they find themselves in over and over and over again, are then going to add 4 lines of code just to implement tracing? I can tell you not all of them. I can tell you not 80%. I can tell you because then their operation teams come to me and they say, I lost track. Developers, we don't have good hygiene all the time when it comes to functions, right? We go out, we create a bunch of functions, we try them out, we may just leave them there. They're unused. The security guys are going to have a field day with that one, right? We just don't. And we can't always depend, and we can't write software in this kind of environment, in this ever-changing kind of switch in the way that we build software. We can't depend on developers to add code every single time that we want to trace something or keep track. I mean, you can't even do that with me. So it's high maintenance, and there's a high potential for errors. You're going to lose something, and complex systems have thousands of functions. I'm not kidding. Like this, there we are. It's responding. That's us. That's our architecture. We're 99% serverless. We have EC2 for our trace collector, but at the end, that's us. In 3 months, 2-3 months, we went from 400 to almost 1,000 functions. okay? And we're small compared to some of our clients. Okay. So this distribution model, imagining that your developer is going to add, and these are individual functions. These aren't like, oh, it's one function, that's been run multiple times. These are individual functions in our application. And I can tell you my developers haven't gone in there and added tracing. They haven't. So can it be done differently? My argument is yes. You can automate the tracing. We, just one example, have built technology that will automatically trace. You add our library, and on the back end, we look at ingress, egress. On the back end, we kind of reverse engineered a bunch of services. We connect all the dots for you, and we present you with an actual trace, okay? I'm sure that we're not the only ones working on this. I'm the only one that I know of, and I can talk from that experience. It's not an infomercial, I promise you, but the premise of automated distributed tracing, whether you build it yourself or you use a third party, is the way to go. Now, all you need to do, in our case, is you have a layer that you enforce everybody use, or a library inside of that layer, and we're sitting on the lambdas, and we'll give you the trace from end to end. We'll give you all the performance metrics. That's what traces do. They'll tell you all the connections all the way through. They're going to tell you how many retries. That little 3, oh, I have this thing. That little 3 right there, that's the number of retries. They're going to tell you when that happens. And you cannot live without this as you start to build out. Don't let that scare you. If you automate the distributed tracing technology that will take you from end to end and give you performance metrics and tell you what happened and tell you when you have an error on that last lambda there, they'll tell you what the initial request was and the payload all the way through. That's what automated distributed tracing is supposed to do, okay? I'm not forgetting about logs. Logs are not going away. I actually had a call with an enterprise that said, Shannon, I spend $5 billion a year on staff just maintaining logs and operations. I want to go away from it. Serverless is the answer. Go. And I was like, well, no. I would love to take your $5 billion. That would be great. But no, it's actually not the answer. We are still going to use logs. But traditionally what we've seen is that you have your APM, and then you're dumping other stuff in logs, right? And our operations teams are looking at the logs, and the engineers are looking through APM and looking for kind of trace analysis and that root cause and trying to decrease that mean time to resolution in their teams, right? Are we running out of time? Oh, good, we're good. One more minute. Okay, anyways, but what we're saying is now that the roles, and this is a highly contested, I won't get into it, but now that the roles of developer and DevOps are shifting a bit, they're getting closer and closer and closer, the trace analysis and the root cause plus the logs are necessary for both teams, period. And so what you need to do is make sure that the tool that you're using, and as you set it up, if you do your automated distributed tracing for your teams, that you can also bring in the logs in line for that particular trace. It's possible, I promise you, okay? So let's go through the examples because we're kind of running out of time. Last thing I want to put in your brains before I leave is you're paying per 100 milliseconds. And these cloud providers, they do really well at communicating with their own services. That's great, especially when you're paying per 100 milliseconds. But you're not only going to use your cloud provider services. You're going to bring in Twilio, you're going to bring in Auth0, you're going to bring in Stripe, right? And a lot of times, and what we're seeing is that it's probably 70% of your spend for your function. On average, okay? It's just something to be aware of, right? Everyone talks about, oh, should I be stuck in a cloud? Oh, I'm cloud. You don't have time to think about that. You need to have velocity in your business. People are using serverless to build software faster than all of you. It's coming, it's happening, and they're going fast. So it's really just your job to figure out how to minimize the damage and to keep track as you build. And there were a couple of talks done about that as well, so I don't have to beat a dead horse. But at the end of the day, those third-party services are really important, and Amazon in particular, X-Ray, isn't going to give you information about the performance of third-party services. They're only going to tell you what's going on in their own environment. So make sure that you keep those in mind as you monitor. This is our actual product. We did a screenshot. You can see that the overall status for a third-party service, Stripe, is bad, right? So this happens over and over again. For us, our costs are probably 60% third-party services and compute. Okay. I think we can go on. We've beat the logging and searching logs across payloads. You all know that this is necessary. I'm not saying logs are going away. You still should be able to search your logs, still track everything, still do a really good job of including identifiers and key identifiers as you grow so that you can actually trace inside of logs, but make sure as you're building your tool that you marry the logs in context of the trace, because that's what's going to be key in reducing. In fact, the tool that we built for our own team, it decreased on average 80 to 90% from troubleshooting time for teams, just by having logs and trace together. All right. Final thoughts. I hope you took something away from this that's actionable, or at least something to keep in mind as you grow. It's not as scary. Serverless is amazing. People are saving 36 to 60% if you hear all the different ranges on their compute. There's below the waterline benefits, including increased velocity, which our friend here talked about in his DDD talk, talking about microservices. Just make sure you use the proper orchestration services. Make sure you automate your observability, and serverless automate your deployment, automate your tests. Automation is key when working in microservices and serverless, okay? And in the end, you go to market faster, and as I tell the developers I work with, you look better and better because you can tie it to business value, and then maybe you'll get parties as good as the salespeople ones, right? All right, thank you very much. I appreciate it. Cool.